All right, so I'm going to do homework number 1, question 3. And it was asking us to find A, B, and C elements of D4 such that A times B equals B times C. And it'd be real easy if A and C could be the same thing, but one of the stipulations here is that A cannot equal C. So we want to find basically three transformations within the square that are going to satisfy this condition here. So if we set A equal to H, a horizontal reflection, B equal to D, which is a diagonal reflection, and C equal to V, we're going to recognize that this is going to satisfy what we're looking for. And I think it's a little bit intuitive that we want to use only reflections as our transformations here, because when we apply two reflections, the original orientation is going to be preserved there. So that's kind of part of how we're able to figure this out. Here we'll show that A times B, it's actually going to be H of D. So we're going to take the original identity square with 1, 2, 3, 4. We're going to apply the diagonal flip. Okay, so if we apply this diagonal flip right here, we can see that the 3 and the 1 are going to swap locations, but the 2 and the 4 are going to stay the same. And then to that square, we're going to apply the horizontal reflection. So right here, we're going to change the location of the 2 and the 1 and the 4 and the 3. And if you take a look, what we end up with is actually the R90 square. So this is the square we get if we rotate the original square 90 degrees counterclockwise. So in order to satisfy this, we need to make sure that B times C gets us the same thing, R90. So that's D of V. So that means the first thing we would end up doing is the vertical reflection. So the vertical reflection is going to swap the 1 and the 2, and then swap the 3 and the 4. And we see that right here with the second square. And then to that square, we're going to apply the diagonal flip. All right, so we are going to basically switch the spots of the 2 and the 4. And once we do that, we see that we get this very same square, the R90 square. All right, so I hope this was clear. If anyone has any questions, feel free to send me a message.